Hello, my name is Rob Robertson, also known as Dr. Rob, and I'm part of the professional services team here at SaltStack, and I'll be your tour guide in this Salt Open Workshop series. We begin with a Salt overview. You may be thinking, but wait, I know what salt is. I use it every day on my food. We're not talking about the familiar white substance with the chemical name of sodium chloride. We're talking about the open source security and automation platform developed by Tom Hatch and managed by the great folks here at SaltStack. So, what exactly is salt? Well, let's dive in and take a look at how it can help create a salty environment. Salt takes a completely different approach to infrastructure automation, founded on the idea that high-speed communication is the only reasonable way to maintain and secure infrastructure at scale. The SALT platform opens new possibilities in system command and control. SALT is a powerful multitasking automation and orchestration platform that can solve numerous systems management challenges across all types of infrastructure, on-prem or in the cloud. The backbone of SALT is the Python-based remote execution engine, which creates a high-speed, secure, bidirectional communication bus for groups of systems such as servers, desktops, network devices, and essentially any other device that you might have a need to manage. On top of this communication system, SALT provides an extremely flexible and easy-to-use configuration management system that uses what we call salt states, which we devote a whole workshop to later. The full power of SALT is available via a master minion architecture. Your SALT master server acts as a central control manager for the clients, which are called SALT minions. The minions connect to the master to receive the instructions and operations necessary to bring them into the appropriate state. So let's dig a little deeper and take a look at some of the features of SALT. Regardless of whether you're working with big data, microservices, high-performance computing, compliance, IoT, what have you, SALT delivers intelligent, modular, and scalable management workflows for IT ops, DevOps, Cloud Ops, SecOps, all of the teams that you might have in your organization. For infrastructures that require complex workflows across these team borders, SALT provides the following features: remote execution, configuration management, automation and orchestration, and cloud management. So let's explore each of these features in a little more detail. Running commands on remote systems is a core function of SALT. SALT has the capability to execute multiple operations at scale across thousands of systems in seconds with a single command. As a function of remote execution, you may want to ensure operations are performed to bring minions into a preferred configuration state. Let's take a look at remote execution in action in a short demo. So in this quick tutorial, we're just going to execute a remote command for all of our minions. So we invoke SALT, target all of our minions, and issue the test ping function. We see that our minions return true, saying that we are in communication with them, and we issue the salt-key to verify all of our minions have returned true and that remote execution command was successful. The SALT configuration management system is based on storing all configuration or state data inside an easily understood data structure. The concepts behind the state system include 1. Simplicity. SALT provides a means to easily administer and manage infrastructure at scale. 2. Extensibility. Not only does SALT provide a core set of modules and functions maintained by SaltStack and the open SALT community, but it's designed to easily add your own custom modules or extend existing modules. 3. Deterministic or idempotent. SALT is founded on the premise that you should be able to execute a command multiple times
on systems and achieve the same results every time. This idempotency ensures that you maintain control over the current state of a system. Fourth, layerable. SALT provides layers of data abstraction, enabling you to execute the same command on diverse platforms without having to know the underlying management tool for each platform. For instance, package management. You execute one command through SALT, and it knows under the hood to use yum, apt, zipper, or the appropriate software management tool based on the operating system. So let's dive into these a little deeper. Providing versatility between massive scale deployments and smaller systems may seem daunting, but SALT is very simple to set up and maintain regardless of the size of the project. The architecture of SALT is designed to work with any number of servers, from a handful of network systems to international deployments across different data centers, on-prem or in the cloud. The topology is a simple client-server model with the needed functionality built into a single set of daemons. While the default configuration will work with little to no modification, SALT can be fine-tuned to meet specific organizational and infrastructure needs at a global scale. SALT is amazingly malleable and provides a core library of modules to build from that can manage the diverse requirements of any environment. As SALT is founded on an open source project, you have the capability to extend modules to accommodate organizational peculiarities that may not be covered by any existing module. This model brings together the best of the remote execution world, amplifies its capabilities, and expands its range, resulting in a system that is as versatile as it is practical and suitable for any network. SALT comes with a number of core functions, such as enabling commands for remote systems to be called in parallel rather than serially, use a secure and encrypted protocol in transferring those operations, providing a simple programming interface, and enabling control over the flow of execution, or being deterministic in how we execute operations, and ensuring consistent and repeatable results are achieved by operations, also known as idempotence or idempotency. SALT also introduces more granular controls to the realm of remote execution, allowing systems to be targeted not just by host name, but also by system properties, which provides a vast array of flexible options to target your systems however you need them to be targeted in your environment. This tutorial illustrates the consistency and deterministic benefits of SALT in your infrastructure, also known as being idempotent. We will apply a configuration state, also referred to as a state run, to one of our minions multiple times to illustrate this point. The first time we apply this state, we issue the SALT command, SALT, with our minion ID and state.sls, and Apache is the name of the state, in what we call test mode, meaning we're not actually applying the changes to our minion. Notice the test run shows that 2 of the 3 components of this state run are already in the desired state. When we apply this state without the test run, we remove that test flag and actually apply the changes for this state. We see the changes that are made to the configuration file. The application packages are already installed and were not reinstalled. And our Apache service was restarted because changes were made to the configuration file. When we apply the state a second time, we see that the system is already in the desired state for all 3 of the components in the state run. Installation of Apache is there, we have the correct config file, and the service is up and running. Salt provides layers of abstraction that facilitate simplicity in its use. Having the ability to execute the same command regardless of the underlying operating system is what layer abstraction is all about. As an example, software or package management is handled with different tools depending on whether your operating system is Red Hat, Debian, or SUSE based. Yes, there are many other operating systems, but these should illustrate the point. If I want to install packages on a Red Hat system, I would use yum. If an Debian, apt, or SUSE zipper. Salt has a module that allows us to run one command and install packages on any of these operating systems without having to explicitly call the individual package managers. That logic takes place in the code of Salt, making management of software simpler for users and administrators alike. Now that we've learned about configuration management, let's take a look at how automation and orchestration can help with these tasks. Executing remote management and configuration operations on a Minion is perfect when you want to ensure that the Minion is configured and running the way you want. Sometimes, however, you want to be able to configure a set of Minions all at once. For example, if you want to set up a load balancer in front of a cluster of web servers, you can ensure the load balancer is set up first and then apply the same matching configuration consistently across the whole cluster. Orchestration provides the means to fully automate configuration management workflows, enabling organizations to scale IT operations at the speed of business. Our Salt Open Source Foundations and SaltStack Enterprise 1 classes provide a greater detail about automation and orchestration. Feel free to reserve your seat today. On to the next topic, cloud management. Salt Cloud provides a powerful interface to interact with various cloud providers. This interface is tightly integrated with Salt management, whether on-prem or in the cloud. Salt Cloud is the system used to provision virtual machines on various public and private cloud providers via a cleanly controlled profile and mapping system. New virtual machines can be managed as well as automatically connected to your Salt master after creation. As part of the overall Salt management concepts that we talk about, multiple cloud providers, as well as cloud instance profiles, can be configured on a single Salt master and has the ability to deploy the Salt Minion as it creates new cloud instances, while managing those instances just as they would Minions on-prem. So let's turn our attention to those Salt management concepts. Now that we've learned about some of the features of Salt, let's turn our attention to some of the basic Salt management concepts. A basic Salt implementation consists of the following components: a Salt master, which is a centralized server to manage systems; Salt Minion, any system or device managed by Salt; agentless systems, systems managed via SSH with the Salt SSH model; and SaltStack Enterprise, Salt for large teams and complex environments. Let's look at each of these components in more detail. A server running the Salt Master service is referred to as a Salt Master. The Salt Master provides a cohesive, centralized platform for orchestration and automation between managed systems. SaltStack Enterprise can be configured with redundant masters. A system under control of the master is considered a Salt Minion. However, Minions do not require a master to be managed, but can run in a standalone mode. The Salt Minion service runs as a management agent on each system. The full Salt Minion agent can run anywhere you can have a Python interpreter. The Salt SSH system was added to Salt as an alternative means to communicate with systems that are unable to use the full Salt Minion agent, a precursor to proxy minions. Salt SSH can be used in tandem with or as an alternative to the standard SALT system. SSH just needs to be running with port 22 open on the agentless system. We introduced this capability of SALT so you can appreciate the full capability that SALT has to offer, but we don't use it in this workshop. SaltStack Enterprise provides an intuitive user interface to perform complex functions like configuration management and orchestration. Jobs in SaltStack Enterprise can be built, stored, and scheduled so you spend less time and fewer resources executing routine functions. It also allows distributing the work to other skill-level employees and teams through full role-based access controls, while securing your system and guarding the environment from the misuse of powerful tools. If you would like to learn more about SaltStack Enterprise, you can do so in our SaltStack Enterprise 1 course. Let's turn our attention now to an overview of SALT's topology. SALT has two basic channels for communicating with minions, 0MQ and Tornado, which we'll discuss in a minute. These pairs of channels work together to implement the specific message passing required by the Open Event System, also known as the event bus. SALT is based on a powerful asynchronous network topology to provide the fastest communication possible. One of the greatest strengths of SALT is the speed of execution. The socket-level event system provides a high-speed communication bus, the event bus. The efficiency and scalability are possible because of the high-speed communication bus utilized by SALT and is more efficient than running a higher-level web service. The remote execution system is at the heart of what makes SALT a powerful and useful platform. The remote execution system is the fundamental concept that all components are built upon. The Open Event System is used for inter-process communication between the SALT master and SALT minions. What this means is that events are seen by both the master and the minions, and those events can be monitored and evaluated by both. The event bus lays the groundwork for orchestration and real-time monitoring. What this means is that all minions see the published jobs by subscribing to events published on the event bus. The associated figure illustrates what happens when a SALT command is executed on the SALT master at a high level. A job gets published to the event bus. Minions monitor the event bus and pull down the job for which it is a target. The minion processes that job, then returns the results of that job to the master and the event bus. Under the hood, SALT uses a pluggable open event system powered by the 0MQ and Tornado, which we mentioned before. And here, just to expand on that, 0MQ is a current default socket level library that provides a flexible transport layer protocol. Tornado is a full TCP-based protocol on the transport layer for the event bus. The default render for many of the files used in SALT is the YAML renderer. YAML stands for YAML Ain't Markup Language, and it is a human-friendly data serialization standard for all programming languages. It is not a markup language like XML, which uses tags to mark text. YAML commonly focuses on data structures, not document markup. YAML is a language with many powerful features. However, SALT uses a small subset of those features that maps over very commonly used data structures like lists and dictionaries. It is the job of the YAML renderer to take the YAML data structure and compile it into a Python data structure for use by SALT. So let's take a look at some of the rules of YAML. There are some basic rules one needs to adhere to when creating YAML files. Data is structured in key value pairs. Mappings use a colon and one space to mark each key value pair. The value of keys can be in many different structures, lists, dictionaries, and so forth. All keys and properties are case sensitive. Comments begin with a hash, octathorpe, #, whatever you want to call that symbol. And tabs are forbidden in YAML. You must use spaces. There are many resources available online to help you with intricacies of YAML. Feel free to take a look at those to learn more about YAML. YAML consists of 3 basic element types: scalars, key value mappings, where the value can be a number, string, or Boolean value; lists, a key followed by a list of values where each value is on a separate line and preceded with 2 spaces and a hyphen; dictionaries, a collection of key value mappings and lists. Let's look at some YAML examples of each of these different element types. Scalars. In our example here, we have our key value pairs all on individual lines that identify vegetables and peas, or fruit and apples being the keys and the values. For our lists, note the keys are on their own line, followed by a 2-space indented list of values. In our case here, we have vegetables, peas and carrots, fruits, apples and oranges. Note for our dictionary, we have our dictionary key, and then indented 2 spaces with no leading hyphens are the key value pairs and lists embedded within our dictionary. So it could be a mix of scalars, a mix of lists, or additional dictionaries. Some last things to note about these YAML block structures. Indentation sets the context. You must indent your properties and lists with 1 or more spaces, but 2 spaces is standard. Tabs are not allowed. Use spaces only. YAML is organized into these block structures. Scalars are your simple key value pairs that can stand alone or be included in lists or dictionaries. A collection, which is a list or a dictionary block sequence, indicates each entry with a hyphen and a space. Thanks for joining us for this first installment in a series of workshops on SaltOpen. If you'd like to learn more about SaltOpen or SaltStack, please register for one of our public instructor-led courses. In the meantime, if you'd like to gain additional hands-on experience with Salt, you can download SaltOpen, request a free trial of SaltStack Enterprise on our website, or access a test environment with one of our hosted tutorials. The next free SaltOpen workshop continues with Install and Configure SaltOpen.